This week's episodes were brought to you by the generous support of Eric Sumner. Hey folks, Quilly18 here, and welcome to another episode of our Unity 3D tutorial for beginners to Unity, where we are making a board game. We are implementing a version of one of the oldest board game in existence, the Royal Game of I think is what it's called. One of the oldest board games ever invented. And we are going to be working on moving our pieces today, because we have this sort of dice rolling thing. We have an indicator for players, and we don't have the player switching yet. That'll happen after we move. What we want to be able to do is, if we roll a 1, this is our starting square here for the player. Obviously, we'll probably want to arc this up a little bit more, but let's get to that later. We want to be able to roll some amount and then click on a tile. And so if we click on this one, we'll go, if we roll the 4 here, we'll go 1, 2, 3, 4, and our piece ends up there. And then as it keeps going, it goes into the middle, and then goes sideways, and then down here. And then when it pop it off that one, we have scored one of our stones. If we do that for all 6 of our stones, then we are, in fact, the winner. There'll be 2 players, and we'll see what we can do about that. So yeah, the goal is, when your turn starts, and we're in this sort of question mark status, you can't do anything. You've got to roll the dice. Once you've done that, then you can go and just pick a tile, and it'll advance that many squares, either one of the ones that are sitting next to here, or one of the ones that are already on the board. So what we want is, I think we need to insert some logic on the actual tiles themselves. Now, we're doing everything sort of very much the Unity way, where everything has their own individual components. I'm also a fan of having like big sort of centralized game controllers as well. There's pros and cons to different approaches. I think here, having everything kind of having their own script is a great way to go. So, on our stones, we've got all 6 stones in here. They're all based on a prefab. What we're going to do is we're going to add a new component on here, and I think we're going to call it something like player stone. Seems like a good idea. So we're just adding a new component. We just created a new C# script over here. I could have gone create and created the C# script this way and then added it to the component, but I've added it here. Now, it's only on this instance of this one stone, not on the prefab right now, so let's make sure to apply it. If you're like me, you're going to forget to do that, and you'll be really confused as to why nothing is happening. Very frustrating. So, we're going to go and implement that. Now, this is an interesting point at this point. Let's say, yeah, let's go with this, because there's actually, we're going to reveal an error with our programming, with our setup right now. So our player stone now has a script attached to it. And one of the cool things you can do in Unity is you can respond to a click on an object in 3D space. And to do that, you simply need to have a function that responds to on mouse down or on mouse up. Some people prefer to respond on the down, some on the up. There's kind of pros and cons. You know what? We're going to go with on mouse up. Because it's actually much more typical in convention for something not to happen when you click down on something, but when you release on some of these buttons. That's much more common, because it gives you a chance to click down and be like, oh, I changed my mind. You move your mouse off it and then let go. So if the player releases the mouse button on top of our player stone, we want to then move that stone. Okay? Obviously, we'll have to check a bunch of things, but for now, let's just put in a little debug.log that says click, or something like that. So when we click on a stone, we'll get a message. Now, this, I think, will not work. So if I click on a stone, nothing is happening. Now, I suspect the reason this is happening, I might be wrong. Might turn out there's something else I'm also doing wrong, but there's one thing I knew would likely be wrong. The problem is this. This script, which is looking for the on mouse up over here, is on the player stone game object here, right? There's player stone script on the player stone object. The problem is that on mouse up, on mouse down only works on game objects that have a collider, and the collider is actually on a sphere graphic over here, this mesh collider. Now, what we could do is we could try to grab this collider and move it down to the base object. And that would sort of work. It wouldn't necessarily... part of the problem is the mesh collider uses the sphere, and if we moved it to over here, it would be a full ball, and we'd have to change the scaling again. And all these things aren't good. Plus, shouldn't the collider kind of always be the same shape as our graphics, and we know that our graphics should really be a child object of the parent. Really, the parent should know very little about the shape of itself in a weird way. So what's the solution? Well, as it turns out, the solution is probably to add a rigid body to the parent object. Rigid body is the thing that actually registers this object in a somewhat more meaningful way in the physics system. Collider by itself means it's something that can be collided in. Now, an object that just has a collider by itself is generally, by the physics system, assumed to be relatively static. It's not supposed to move. If something has a physical collider and moves, it should probably have a rigid body. Now, by itself, I go and let's say I take this up over here and then hit play. Having a rigid body means it's going to be affected by various forces, like, for example, gravity, which pulls it down, and then it doesn't collide down here because mesh collider things and whatever. We don't actually want it to be affected by physical forces like gravity. We want it to be registered properly as something that might move in the physics system. Again, we're not really going to use the physics system exactly, but we do want this to be a little smarter. If we set that it is kinematic, now what we have is something that's a lot smarter in, I'm going to apply the changes, something that's a lot smarter in the physics system in terms of collision, but isn't actually affected by external forces. So let me just go and reset you to the 1 position. And let's test something. If I go and hit play now and click there, aha, you see how it's responding to click? The reason for that is the rigid body, in addition to sort of registering things a little bit more in the physical system, what it also does is it looks at, the rigid body looks at this game object itself, as well as all of its children, takes a look at all the colliders that might be part of this object as a whole. Because one object, especially with a lot of subchildren, might be made up of many different colliders. And it sort of just like groups them all up in one little pile and knows what they all are. As a result now, even though we don't have a collider on this base object, because we have this rigid body, this player stone script will now get mouse commands interacting with that rigid body. Now, there are a few gotchas here in that if you end up in a situation where, let's say, okay, here's actually a good example. You see the roll the dice button here? If I click here, I'm going to roll the dice, but you see how I'm also getting the click, click, click? Because if I have my mouse right here, the mouse is both over this user interface element and the stone behind it. So the stone's saying, yeah, I'm totally being clicked on, but is that what we want? Well, sometimes it is, and sometimes it's not. In this case, I would suggest we don't want the stone behind this button to necessarily get this command. But we may have to leave it in there for a sec, just because it's possible that some of this stuff will get in the way. So I'm going to leave it in there for now, where it's going to get the command. But later on, we will be able to do a check. In here, we're going to put in an extra little check to say, like, here, to do, is the mouse over a UI element, in which case ignore this click. Okay, that's something we'll probably do later. All right, so we have it responding to clicks, which is good. So our actual logic is going to be something like this. Have we rolled the dice? Also, to do, is it our turn? We'll deal with that after. Have we rolled the dice? How can we know if we rolled the dice? Well, the dice roller has the done rolling, true or false. So let's go and grab dice roller, the roller. Okay, we're gonna grab a reference to it, exactly like we do here in dice total display. So we're gonna find the dice roller. Oh, the dice roller. There we go. We're gonna find the dice roller, and we'll say something like, if the dice roller dot is done rolling. You know what? I want to change the name of this. For Booleans, it's often better form, and this is public. It should start with a capital letter, just for like consistency. We're going to call this is with a capital I done rolling. So if is done rolling. So I'm just going to save these files. Save, save, save. If is done rolling. Move this stone. Okay? Or maybe it would be better, instead of having a bunch of nested ifs, right? Because we're going to do a bunch of logic tests in here. Instead, we're going to say, if we're not done rolling, if it's false, we could also put a little exclamation mark over here to invert this. I like to be explicit. If is done rolling is false, then it's not time for us to move. So let's just return. let's just bail from this function and not go any further. We're just going to ignore this click completely. That way, if we get down here, we know we're good. Tends to keep your code a lot cleaner, and it avoids this problem where you have like these like crazy nested ifs, which are really hard to read and prone to errors. So if our state isn't good, GTFO, we're going to get out of here. So now we know that we can move. So what is, so what's the correct solution? Okay, so it's done rolling. So int, let's say spaces to move is equal to the dice roller dot total. There we go, dice total. So that's how many spaces we're supposed to move. So how do we do that? We need at this point to know what the list of sort of like movable tiles is. Right? We need to know how we're supposed to move across this board. We went and like named everything. So we got, you know, player. You know what? I just realized at some point I flipped the player 1 and player 2, which might be okay. Like I can just move all the player 1 stuff to the other side. Let's invert this. All the player 1 stuff, I'm going to grab all of it. And instead of being at Z1, I'm going to set it at Z -1. And then all the player 2 stuff, I'm going to set it at Z +1. Like that. There we go. So now player 1 start is over here. Good. So it goes 1, 2, 3, 4, and then we get into the middle, 1, 2, and so on. But how are our pieces actually know? I mean, we could do something with the naming, sort of maybe, although then you still have to be aware of player 1 versus player 2. One thing that works quite well, like we could have an array of all the valid moves per player. That might be okay. The other thing that's quite nice is you could just sort of tell each tile which one is the next tile along the way. That will work everywhere except right here we do need a branch option that we can take a look at. I think that's probably going to be fine in this case. And also, it's quite a neat way to do things. So with our tiles, and these tiles, despite having different names, are all based on the same prefab over here, this tile prefab. Let's add a script to this. And heck, let's do it a different way. We're going to go create script. It's going to be called tile. And it's not in the prefab folder. We're going to put it down here. Actually, what I should probably do is make a new folder for scripts. Let's keep our project nice and clean and organized. So I'm going to move you in there. So this script that we made over here is a mono behavior. It's ready to be attached. So I could attach it to the cube that's in here and then apply, or I can attach it directly to the prefab over here, which is what I'll do. I'll attach it to the prefab by just dragging it over. And then if we look at the board, all of these will have this tile script. Great. So now we have this new tile script available over here. And what I'm going to do for our tile script is we're going to have something like next tile. Okay? And this could just be literally something like public tile next tile. Now there's a slight problem with this because sometimes there might be more than one. If you were making, let's say you were making a digital version of the Game of Life, right? The board game, the Game of Life. It's got quite a few different branching options, and the player actually gets to choose in that game which branch to go down. Here we don't get a choice, but branching is still kind of a thing. I think what should probably happen is just should be an array, maybe called next tiles. Most of our tile will only have one thing in here. Some might have more than one. So let's take a look at that. That is compiled. So start 1 over here. The next tile for this is going to be the start 2. So we can just drag it in there and it sets it. Awesome. And then start 2 will go to start 3. And start 3 will go to start 4. And start 4 will go to middle 1. Middle 1 will go to middle 2. I mean, this is only one of many, many, many ways to do it, but this lets you link things in the editor. It's also quite nice. Let's say you decide to offload your map design. Oops, I did that wrong. Middle 3 goes to middle 4. Middle 4 goes to middle 5. You know, you could give it to like a game designer who will then be able to like redraw the map and do different things like that, which I think is quite spiffy. 6 goes to 7. 7, 8, 9. Now, middle 8 is the special one in that it'll go to either end 1 or, it's actually a size of 2, or player 2 and 1. So player 1, player 2 will probably use the index here to make a determination if there's more than one option. Player N1 goes to N2, and N2 goes nowhere. And again, we'll catch that special case in that particular scenario. Player 2 N1 goes to player 2 N2, and then N2 goes nowhere. So now we've got a series, we've got a linked list, is what we've done, of how to get through this entire array. Of sort of a linked list with like a weird little branching kind of thing over there. So the tiles can actually figure it out. Now, as long as we've got something like, this is your starting tile, then we're good to go. So for example, we might want to have on your stones, oh, that's the material, let's shrink that. Player stone 1. So we have like this player stone script over here, right? Let's say in the player stone script, we go ahead and get a public tile starting tile. Save this. So for player 1 stones, their starting tile is here. Oh, oh. Right. This is a prefab. I can't link to something that's in the game this way. Okay, that's fine. Ish. Okay, so we're not going to be able to link it in the prefab. That's fine. So these are all the player 1 stones. I'm going to select them all, and then for their starting tile, do that. So I'm not going to set it in the prefab, but in here. So all of these stones know what tile they're supposed to start in. Good. Okay. Good-ish. Sure. And then we know from each tile which one is the next one along the way. I think we've got what we need to get this moving. So what we want to do for our tile, right, we know how many spaces to move. And what's interesting about this is then we can figure out where we're supposed to end up. Not only that, we know everywhere we're supposed to go along the way. Let's do the first bit first. Well, let's do what I said first, and then we're going to make it way cooler. So we need to know, where should we end up? And in our first iteration, we're just going to teleport to the final square. But then we're going to do a really cool animation for it later on. Where should we end up? Question mark. So I think we should know what our current tile is. So this starts with a lowercase because it's a private or protected, whatever the default, I think it's private over here, thing that we keep track of internally. This does start off set as null, okay? So where should we end up? So we want to end up a number of spaces forward from where we are. So in the situation where our current tile, well, first of all, if spaces to move, because we can bail out early, if spaces to move is equal to 0, which could totally happen, we can roll a 0, then we can just return. We're not supposed to move anywhere, so just bail. If our current tile is null, okay? If that means we're on the sidelines, we haven't started moving yet, then what we're going to do is we're going to say, actually, that's a really good question. I guess, okay, here's what we're going to do. Tile, final tile, is going to start as null. You know what? We don't actually need to do this check. Also, this is supposed to be final tile. So we're supposed to end up somewhere. If our current tile, so then we need to do a loop. There we go. For I is less than, say, spaces to move. There we go. We're going to advance final tile. If our current tile is equal to null, then in this iteration, we set final tile is equal to starting tile. Otherwise, we set final tile to be equal to current tile dot next tile 0. We're going to do this a little bit better in a second here. What's going on? So we're going to loop through this X number of times. Let's say we rolled a 2. So this is going to go twice. When we know we start with current tile is equal to null, so the first loop through here is going to set our goal tile to be the starting tile. Then the next loop through There we go. If we rolled a 0, our final tile will be our current tile, which might be null. That's okay. If final tile is set to null, then on this iteration, go to the starting one. Otherwise, the second loop through, we go to the next tile after the starting one. So with a roll of 2, we end up on the tile after the first tile. On a roll of 0, we end up with our final tile be equal to our current tile, which might still be null, right? So at this point, we can leave a thing like, if final, well, there you go. Yeah, probably something like if final tile is equal to null, then we moved an off-board tile by 0. And in practice, I think if the player rolls 0, I think you'll just end the turn right away rather than wait for a click. But we may as well do a check for this and just return right away. Okay. Otherwise, what we're going to do is this. Teleport the tile to the final tile. To do. Animate! So what we're going to do is this. We are going to set our position to be the same position as the final tile. Now, at the start of the game, all of our pieces are in the player, what do we call it? Let me scroll. The stone storage area here. We have a parent because we're staying nicely organized in the stone storage area. I want to bust out of that is what I want to do probably. Well, we don't even have to do that. Because as long as we set parent thing... No, we're going to be okay. Okay, tell you what. So what we're going to do is we're just going to teleport to our final tile at this point. So what we're going to do for this stone, we're going to set this.transform. Again, you don't need the this, but I like it for clarity. Dot position is going to be equal to the final tile dot transform dot position. And because of the way we've set up our graphics, if these two positions are the same, it'll make it look like our stone is sitting on top of our tile. Let's give that a try. So, current tile is never assigned to. That's fine. So, if we roll, we've got a value of 2. If I click here, oh, we get an error. What did I do wrong? Oh, right. Hold on. We've got to loop through the final tiles here. It's not current tile, it's final tile. So we just keep advancing this way. That's good. And really what should happen is at the end of all this, not that it matters, but current tile should be set to this final tile at this point. Okay, let's try that again. We're going to hit play. Roll the dice. Okay, value of 3. I'm going to click on this stone, so it should end up right there. And it does! And then, I mean, I could click this one again. It should move forward another 3, and another 3, and another 3. And then I think if we do it here, we'll get an error. Because, yeah, it's supposed to move off here, so it's getting set to null, which is an error, which we just need to score it and do something different, but that's okay. Then I can click on this one. I could roll to a different value. Let's get, hey, a 1. There you go. 1, 1. I can do this. 2 things will both be in the same place, which we don't want to allow later on, but for now is, you know, kind of okay. There we go. We've got some movement. Excellent. Fantastic. Wonderful. Let's go and... let's put in a little thing here. It says... Oh, right, because we're trying to read this. We'll have to do a couple of checks on next tile here. So first of all, if next tiles dot length, or if it's equal to null, or final tile dot next tiles dot length is equal to 0, double equal, we have reached the end and must score. So we'll just do it like debug.log score. And I don't know, destroy game object to remove it from the thing, and then return right away. We'll do something like that. We'll just remove ourselves from the game. We'll figure something out after. To do. There we go. Else if final tile dot next tiles dot length is greater than 1. Branch based on player ID, because this is a tile where we've got a choice. And then finally, the default behavior is just to grab the first one over there. So if it's greater than 1, we got to do a little bit of a branch, which requires us to do this. We don't know what our player ID is here yet. We're either going to be player 0 or player 1, and we're going to pick a correct direction based on that. We'll come back to it. That should get rid of that error anyway. So now if we were to hit play, roll the dice, click U, and advance, and advance, and advance, and advance, and advance, and one more, and if I hit it again, it should score. Score! And the thing removes itself. Excellent. Okay. So obviously we still need to do a few things. We need to have checks. Is a tile occupied? And is it occupied by a friendly? If it's occupied by a friendly, I'm not allowed to make this move at all. If it's occupied by an enemy, I can make the move, and then I got to go and bop the enemy back to his starting area. Cool things like that. But that's advancing. It's very nice. I think this should be animated. Although I have to say, the very fast little movement is appreciated, but I think we can throw a little bit of animation in this. So I think what we will have to do, because the animation will take a little bit of time, not a ton of time, but a little bit of time, we're going to go ahead and put a cut in here, and next episode, we're going to animate the movement from tile to tile, have it go along the way. It feels like, players actually moving a stone and maybe counting along or something like that. Thanks for watching, folks. See you next time. Thank you to all the October patrons who make these videos possible, including these Mike Check supporters: Yoko Finn, Eric Sumner, Adam Keenan, Danny Welch, Tiburon, Mighty Mix, Pavel Zdanov, Michael McClintock, Aaron Tyson, Rorskal, Gurko Dries, TNSEE, Jasper Bisgard, Julien Gelafon, Marius Field-Vold, Speedy Savant, Steven Stager, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Easter Egg Productions, and Neil Blakely Milner, as well as everyone who likes, favorites, and subscribes to these videos. Thank you very, very much.